Okay, so welcome to System Administration and Internet Working. My name is Vas. Contact details for me. Your best bet if you ever need to find me is to have a look in lab a2.net. That's our networks lab, and it's located at the other side of this corridor on the second floor in Anglesey building, because I am basically a lab rat that lives there. I do have an office. I'm almost never there. It's in A202B. And of course, you can always email me, and my email address, same as pretty much every other member of staff in University of Portsmouth, is firstname.surname@port.ac.uk. So it's vasilios.adamos@port.ac.uk. So what we'll be doing for this module is we will have some lectures to begin with, and then we'll have some practical sessions in which you will work your magic in the lab and try to basically complete the lab sheets that we give you that you need to do. So we will have 4 lectures to assist with the theory, and we'll have 6 lab sessions to complete the practical work. And at the end of all of this, so that's I think Monday the 11th of December, we will have an assessment session, and I will explain to you how this actually runs. So you will be working in the lab in a2.net. And we used to have the option, this is the first bit of bad news, isn't it? We used to have the option to connect remotely and work. This started happening during the pandemic because we had to work from home. However, it has caused lots and lots of problems since we started coming back to class. So it is under consideration for this year, but unless something terrible happens, we will not allow remote connections anymore. Okay, instead, the lab will be open until around 9 o'clock in the evening, and the lab is generally open access. So unless there is another practical session running in the lab, and specifically there is somebody sitting and working on your computer in the lab, you will be able to go into the lab and work as long as you like. So basically, if there is another lab session, so if there is another lecturer running a class in there, but your particular computer is free, because remember, you will be allocated a computer in the lab the first time you go to the lab, you can go in, as long as you switch your phone off or set it in silent, you can sit on your computer and work, and you don't need to worry about anything else. Okay, so you can work in the lab during our timetabled lab sessions. They will run on Mondays. It will either be a morning 9 to 11 or an afternoon 3 to 5, if I remember correctly, session. And you can work on the computers there when your computer is basically free, whether there is a class in there or not. Right. The assessment for this module is done through 3 assessment artifacts, as we call them. The first one is My Logbook. So you'll have to complete a logbook that details all of the work that you've done in the module for the 6 weeks that you're working on the practical lab sessions in the lab. You'll need to do the same thing for Linda's side of things as well in teaching block 2. And in the end of all of this, we'll have the exam period, which will run sometime in the middle to end of May. And you'll have an exam, which will be a computer-based test and last for about an hour. And we will test you in that exam on everything that we've basically done throughout the year. Notes and all required material is located on Moodle. If you haven't been to moodle.port.ac.uk yet, please go. Everything that you need to know about your studies is located there. You will have a list of all of the modules that you're being taught. If you do log in and you go to your dashboard and you look at your modules and you cannot find a specific one, I've already had one of my tutees face this problem, you need to email techocd@port.ac.uk and tell them, hi, look, I'm studying computer networks or whatever, and this particular module is not showing up on Moodle for me. All right, so they will fix it, and they are relatively fast in helping as well. Now, the lab itself is a2.net, has scheduled lab sessions plus open access. So this means that you can come and work in the lab, as I said, whenever you have a timetabled event. You cannot generally log into those computers in the lab with the same credentials as all of the other computers in the university. Okay, so your UP student number, username, and its corresponding password will not actually work in there. When you do come into the lab for the first time, we give you a username and a password so that you can work there. It's either VM1 to VM12 and whatever password that comes with it. Okay, you change the password to something that's yours so that nobody else can log in with your username and password on that specific computer, and then that computer will basically be yours for the rest of the year to use. Okay, so that student account, that username, the VM, whatever username we allocate to you, and all the work that you've done onto that computer will only be accessible by you, well, okay, by me as well, until the end of the year. All right. Now, the computers will be allocated in the first practical session, and that's on week 5 or 6, whenever it is. And lab session changes are not possible because it messes with our attendance monitoring system. So if you do have your timetable and it shows that you're in a morning session and you'd prefer to come in an afternoon session, you can't. Okay. So have you all checked your timetable, basically, to have a look when the labs run? All right. Okay. So if there is an incredibly important reason that you need to change sessions, okay, you need to tell us, you need to tell me basically, and we might be able to help. All right. It is a bit of a hassle because we need to inform central timetabling and everything about it, but it is possible, but it is quite a lot of work and we don't want to do it for no reason. All right. For example, my favorite reason is I'm in the 9 o'clock session and I want to move to the 3 o'clock session because I don't like waking up in the morning. Yeah. So check which lab session you're in and make sure that you can make it. If you cannot, if you're working and you cannot change your shift or something like that, then tell us and we'll try to accommodate you. All right. Schedule for the lectures. So what we'll deal with, when you come and work on your computers, you will basically have a Linux computer. So what we use here is we use CentOS 7 on our computers in the labs, and you will have a virtual machine that you will need to build. That virtual machine will be your basis of operations. So it will be your host that will contain everything that you do inside it. The reason that we do this and the reason why you're not working physically on the computer itself is A, because there are 11 more user accounts on that computer, because we have to accommodate multiple classes from multiple different units that work on your computer. And most importantly, if it's a virtual machine, you can make a backup of it after you complete the lab set. You can move on to the next one. If you break it, you can just restore the backup. It means that if you mess up your system, kill the hard drive, whatever, you won't have to start all over from the beginning once this happens. Okay, so we do work on virtual machines, so this means that each of you will have your allocated username and password, and then once they log in, you will have your allocated virtual machine that you will log in, you have to build it and use it. When I say you have to build it, it means that you have to create the virtual machine itself, and you'll have to install the operating system inside it. So once you install the operating system inside it, you need to familiarize yourself with the Linux operating system. So hands up if you've used Linux before. That's very promising. Good. Familiarize yourself with the operating system, where everything is, what commands we need to know, and so on. Then we'll deal a bit with VMware. So essentially, we will do some nested virtualization. So we'll build some virtual machines inside that virtual machine that you're already working on. Our computers can generally take it. They are quite strong. Xeon's plenty of RAM and NVMe hard drives. So you install VMware and you'll build, if I remember correctly for this module, 4 virtual machines inside there that you'll be able to play around, network them together, and try out various different services that you need to install in there. You need to try out routing. So we'll do a little bit of routing because it's a networks lab. So we'll do, I think, if I remember correctly for this one, it's OSPF. So we'll convert one of the hosts that you have in there into a router. So you need to configure all the configuration files, the corresponding services, packet forwarding and everything else, and get some routing going in your little network. And then finally, once you do that, you also need to configure and set up a DNS server to work for that little network. Essentially, you're building the basis of a virtualized environment, of a neighborhood of virtual machines that can provide various services to each other, to the clients that exist in the network itself, and possibly to other computers outside of it as well. All right, so the idea behind it is first to learn how to deal with Linux operating systems, secondly virtualization, and then thirdly how to deal a little bit with services that the network can provide, that the system can provide online, which essentially forms the basis of operation of how a cloud system actually works. All right, so you have a bunch of virtualized resources somewhere, and they provide some services either to themselves or to their neighboring computers or to some third-party computers completely outside that particular cloud. So this is what we want to get you familiarized with. If you have experience on something like this before, it's great. The module runs at its own pace. So once I release all of the lab sheets, I will release all of the lab sheets in one go. And this will probably happen at some point next week. All right. If you feel like it, you can start working on this before you actually come into the labs. The only thing that I ask is that you don't email me every 5 seconds and say, Vas, this doesn't work. Vas, that didn't work. All right. If you feel like you want to take this on your own, you're on your own until we go into the labs. When we're in the labs, don't be afraid to ask questions. All right. There are no stupid questions. Well, there are, but you can ask whatever you like and we'll help you. Our job in the lab is to help you progress with your work, understand what it is you're doing and why you're doing it, and move on with it and get everything configured and learn something. Okay. In the lab, there will be me and there will be 3 more teaching assistants that I have. It's my latest toy. I have them since last year. It's great. So they are master students that have seen this before and they know what they're doing. I hope they know. And they will help you. Okay. So you don't be afraid to ask myself or them any question you have. It doesn't mean that if you ask me a lot of questions, I will think that you're useless and then mark your logbook down. Yes, it's only the end result that matters. And if you do truly know nothing, you're the Jon Snow of the class, I will be happy to teach you absolutely everything and help you progress with it completely. Okay. So when you're in the lab, you can ask any questions you like, myself or the teaching assistants, and you can basically move on with all of the material. If you think that you're finished faster, so if you see that it's the beginning of November and you've done everything, ask me and I can give you some additional tasks to perform. Okay, the whole point of the lab is that it's a playground for you to learn how to do stuff. And in fact, if you think that you are finished with all of the material that we have to give you, you can actually create your own completely separate virtual machine, install whatever operating system you want on it. You will be familiar with the networking rules of the lab by then, which basically means the IP addresses that you can use or you cannot use and so on. And you can install and try out whatever you like. Okay, any operating system, any technology, whatever you like. The lab itself is isolated in 2 ways from the outside world. Okay, so there is a firewall and there are some routing tricks in place as well. So no matter what you do, you cannot really affect the rest of the university. It's an isolated place. So the only real damage that you could cause is, I don't know, make a computer catch fire. Hasn't happened yet. We have fire extinguishers, it's fine. Give it a try, So you can play around, you can experiment with whatever you like. Maybe you heard about a new operating system and you want to try it out. It's fine. Build a virtual machine for it, install it, play around, and it's not a problem. Okay. So the logbook itself. So you're in the lab, you're working. We need to have a way to assess your progress. We need to have a way to mark you and say, yes, he or she or they understand everything that's happened. They've learned it. They know how to do it. We give them A. Me personally as an assessor, I always want everybody to get a first class mark. Okay, so when I start marking somebody, I start marking them from 70 and I either mark down or up. Okay, I don't start from 0 or 40. Okay, so there are a few rules to the artifacts that you will need to submit. The logbook and the exam. The exam is pretty basic rules. I'll go through them in the next slide. The logbook itself needs to be a Google Doc that you create in the beginning of the teaching block, and you keep it until the end of the teaching block. You update it regularly every week when you're working, okay, and you put there all of the information that you've generated while you're working in the lab. Essentially, when you're working on the computer, you're building something, you're building the virtual machine and so on, you can take screenshots. There are lots of screenshots utilities in the operating system itself, and you can basically take those screenshots, stick them in the logbook, pen them in the logbook, and write a couple of words underneath explaining what it is exactly that we're seeing, and most importantly, why you've done what you're doing in that specific way. So your logbook needs to tell me that you've done something, but most importantly that you understand why you've done that something in that specific way. Okay, the why is the most important aspect of the documentation in the logbook. There is no limit in pages or words and everything in the logbook. Theoretically, there is a limit of 3,000 words. Okay, but I never really count words or anything like that on it. All right. What's important is that you have all of the work that you've done step by step, and you explain it there step by step. All right. If you want to have an excruciating level of detail, it's fine. I've had logbooks in the past that were about 250 pages. Okay, if you think you want to do something like that, it's fine. Other students will have 0 pages, so it kind of evens out. So, you keep a documentation, you perform all of the tasks that are required of you in the lab set, and you explain those tasks in the logbook. There is a certain structure that you can adhere to if you want to, so you can have sort of preparatory work, methodology, configuration, testing, results, retesting and results, if whatever you did didn't work the first time around, and some conclusion in the end and so on, but it's really up to you. Okay. Generally, the idea is that you show me that you understand in the beginning of the lab set what it is that you think you're doing, and at the end of the lab set, you show me that you built the thing, it works, and you understand how and why. All right. So the logbooks need to be Google Docs. The most important reason for this is data backup. All right. If it's a Google Doc that exists on your university account, it means that the university is actually responsible for it, and then it basically means that Google is responsible for the data integrity of it, so you can't really lose it. And if you lose it, it's not your fault. There is a process in the university that's called ECF, Extenuating Circumstances Form. I'm pretty sure you've been told about it already, yes? So one of the reasons that is not accepted in ECF form is my laptop broke. All right. So any hardware failure on your part isn't a problem if your logbook or all of your coursework for all of your modules essentially basically lives on your Google Drive. Your email addresses from the university are Google email. We use Google Apps as a company. Okay, so you have Google Drive, you have Gmail, you have everything else. Use it because it's there for your benefit. And we pay a lot of money for it. All right, so it's the best and safest way to do your coursework. For this particular module, there's one more reason as well, because the document that you're creating, you will need to put screenshots in it, and all of this is happening in Linux, remember? Things sometimes don't work as you want them to. So the best combination of software for you to use while you're working is to install the Chrome browser, get your screenshots, have your drive open on the browser, and then take all of your screenshots, copy and paste them in your logbook as soon as you take them, and that's it. Your screenshots live in the logbook itself. Lots of students like to take the screenshots and store them locally on the computer. It's a big no-no, because the computer itself is a computer that 7 or 8 other people will be using at the same time. All right, so that hard drive is not 100% safe. Even worse, other students have been taking screenshots and saving them inside the virtual machine that they're building, which is the absolutely worst thing that you can do, because you will most likely kill that virtual machine at some point and you lose all your screenshots. All right, so the safest thing to do is take a screenshot from the snapshot utility, just paste it straight away into your Google Doc, into your logbook. All right, don't even store it locally on your hard drive anywhere. All right, so there's some best or better practices for what you're actually doing. All right, so the Google Doc that you will create, I will need to eventually see it. So you will need to submit that Google Doc on Moodle. There will be a Turnitin submission inbox, as we call it. So you will need to download that document from Google, turn it into a PDF, and submit it into Turnitin. Okay. Any coursework that you submit should be in PDF format. This is the easiest way to ensure that the format of your work is as you would want it to be, because you might have created a document in Microsoft Office or in OpenOffice or anything else. Nothing guarantees you that when we open it on our system, it will look exactly the same. The only way to do this is to convert it into a PDF, which is essentially printed format. Okay, PDF, printed document format. And you can submit them to us that way, and you'll know that they are the same. All right. So the other thing that you will have to do about your logbook is convince me that it's yours. So in that last session on the 11th of December, you will need to come into the lab with your logbook, your Google Doc or PDF format open on the screen. I will scan through it, see the work that you've done, and I will compare the work that you've done with the work that exists on your computer. All right. If I see differences, or if I see something that's too fancy and they've never seen you in the lab, I will ask questions. And I will ask questions until I stress you enough to break and tell me, no, somebody else did it for me. All right. So yes, you will be checked on your work. All right. It's better to come into the lab a few times, do a little bit of work and hope to pass, rather than thinking that you can trick the Greek and pass with somebody else's work. Yes? All right. Good. Not that it hasn't happened, fine, but, the chances are slim to none. All right. So, logbooks. The exam, very easy. You'll have about 50 questions. You'll have about 1 hour to do them. It's a computer-based test, and it will be during the exam period in May. The questions themselves will be multiple choice, multiple response, some matching questions. The worst kind of question that you can get is a fill in the blanks type question, which basically means that you need to actually type something. But the thing that you need to type will most probably be a command, something. Okay. And commands should only be typed in a specific way. All right. All small letters, and then you have the command, the option, the argument, and that's it. Okay. Other than that, that's why, and you will have about an hour to do this, and that's why there's so many of these questions. They are quick questions. All right. There are ways to deal with such a big number of questions in the exam, and the best one is to look at the question. If you know the answer, answer it, move on to the next. If you don't know the answer, move on to the next, and then go through all of the questions this way. And then once you've gone through all 50 of them, you can go back and realize that, okay, you've answered more than half of the questions straight away. You still have 15 minutes remaining in the exam, and you can take your time with the rest of the questions. Or you have 10 minutes left in the exam and you've answered only 10 questions and you should have studied more. Okay, so it's not something particularly difficult, and we do have mock exams that are available to you and you can practice on before you actually come to the exam itself. Okay, the material in the exam will be only from everything that we've done in the lab. So if it doesn't exist in your logbook, it will not exist in the exam either. Okay. Recommended reading, anything you can find on Linux, particularly Red Hat flavored Linux, because the CentOS that we're using is actually Red Hat Enterprise Linux. There is a reason why we use this, because Red Hat is the best. No? All right, fine. Red Hat is one of the oldest distributions and one of the most widely used in the industry, and that's why we use them. Yes, Debian is good as well if you're a good hacker or whatever. Yeah, but we're using Red Hat here. All right. So You can use this book. There is an online version of it, so you can find it in electronic format if you look enough or you want to buy it. Okay. Everything else that you will need for the module itself, Google is your friend. We have our library as well, and it is an online library as well. So you can find some resources there also. And that's it. It took me 20 minutes, sorry. Any questions about all this?
Question.
Yes.
Recommended reading, I saw ISBN. What is that?
This is so every book has like an ID on the planet. So each book has its own ISBN number for all countries everywhere. So there are, I think, 10 number and 14 number ISBNs or whatever it is, 10 and 13. So if you just type the ISBN in your search, then the book will come up. Okay. Anything else? Okay, so next week, yes?
You said there were going to be mock exams available. Where do we find them?
They will be on Moodle. So everything you need for the module will eventually, or from next week, be on Moodle itself. Okay, thank you very much. See you next week.